Okay, so notice the units. That's very important. Dollars per year. You can also tell that the investment is increasing in value. That the investment is increasing. Why? Well, I tell you here that it's growing linearly. Now, why didn't I put that in the second slide? I don't know, but it is growing linearly. And if it's linear, that rate of change is never going to change. The rate of change is constant. So we have it's positive. That tells us the rate of change is positive. It's increasing in value. Notice also, you should have, like, once you knew it was increasing linearly, from the question alone, you know you should get a positive slope, a positive rate of change, right? Because as time increased, the value of the investment increased. So from there, you should have been able to determine that the rate of change is positive. That's useful because what if you, by mistake, mixed up the order of subtraction? I mean, subtraction is not as nice as adding. It's not commutative. Well, if you did that, you would get a negative answer. If you mixed up the order in the numerator or the denominator, you would get a negative rate of change, which we knew would be wrong, right? Because again, by the wording in the question, the rate of change is positive. Okay. Are there any questions about this one? Okay. Let's do another one then. So let's say we have a shirt that was marked, you know, on the price tag or whatever at $24.95, but it rings up at the register $19.96. What is that percent discount of the shirt? Right, so I guess it's on sale or something. We didn't know about it. We thought it was $24.95, but it turns out to be $19.96. So there's some kind of discount. What percent discount is it? Remember, this is absolute change and relative change, which becomes percent change. Right? Okay. Basically, we want to know by what percent did the price of the shirt decrease? By what percent? Okay, well, remember, what do? You get the absolute change, which is the starting value, excuse me, the final value minus the starting value. That's the numerator here. That's the numerator. Okay, it's the ending value minus the starting value, which is absolute change. But then you have to divide by the starting value, which is the $24.95, right? It begins at $24.95. By the end, you know, it's $19.96. And if you do this calculation, this is what you get. Something wrong there? Hold on a second. I think that calculation's a little off. Let me just double check. Oh no, I'm right. Never mind. I thought the calculation was wrong. I just double checked. But basically, we get negative 0.2 here. Negative 0.2. And of course, when you convert that to a percent, that's negative 20%. That means the percent discount is 20%. It had a 20% discount. Okay, I thought this was, for some reason, I thought the calculation was off, but it's right. So my mistake. But again, it's a 20% discount. So that's good. All right, that's one example. Let's do another one. Let's suppose two people here Anthony and his son, John. Okay, these names I came up with randomly, although I think it's from the book actually. But they're exercising more regularly together. They're keeping track. I guess they want to lose weight together. It turns out they both lost 10 pounds. Well, let's assume Anthony, his starting weight was 190 pounds. And let's also assume John's starting weight was 155 pounds. Okay, they both lost 10 pounds, but these are the starting weights. Who lost a larger percent of their weight? Okay, well, we have percent here. We have to calculate that. Okay, so what does that mean? Absolute change and relative change. Although here, notice the absolute change is actually given to you, right? They lost 10 pounds. So they're telling you that their final weight, their final value, minus the starting value or their starting weight was 10. So they're telling you the absolute change here. The starting weight, they tell you, for Anthony is 190. And for John, the son, it's 155. So we have these calculations, right? You know, on top, we have the absolute change, and we have the starting values on the bottom, and then we just do the calculations. And notice the absolute change, the numerator has to be negative. They lost 10 pounds. They didn't gain 10 pounds. They lost 10 pounds, right? So the final value is bigger than the starting value, right? Remember, it's final value minus the starting over the starting value. I think I might have said it backwards. The final value is less than the starting value. That's what it is. Okay. So basically from here, Anthony lost 5.3% of his weight. John lost 6.5% of his weight. So John lost a larger percentage of his weight. I mean, they both lost 10 pounds, but John lost a bigger percent. Okay, again, the numerator, the absolute change, right? It's the ending value minus the starting over the starting. So ending value minus the starting value over the starting value. And they basically give you the starting value here. They don't give you the ending value, but that's okay because they give you the change. So here it was 190 for Anthony. John's starting weight was 155. Although you could get their ending weights you can get. Now, let's suppose A was not given. A was not given, okay? So A is gone. Let's say we only knew they lost 10 pounds. Can we determine if they both lost the same percentage of weight from the original problem? Well, it turns out you can't. So if A wasn't here, what I'm asking is, can we determine if they both lost the same percentage of their weight? Well, no, because we don't know the starting weights. A gave us the starting weights. The problem itself only gave us the numerators here, but part A gave us the denominators. And we don't know the percentage either, so we wouldn't be able to. So just knowing how much they both lost is not enough to determine who lost a greater percentage, is what I'm trying to say. Okay. All right, let me ask. I feel like let me just ask this though. Polling, here we go. Okay, does this make sense? I want to make sure it makes sense. I feel like part of me feels like I over-explained something, but I think most people get it. It's really just the formulas is what it boils down to. So come on, everyone. Answer the polls. Thank you. Good, good. All right. Very good. I mean, I don't take attendance anyway, so I know some people aren't here, but hope they're okay though. That's right. Can't believe it's March already. All right. Okay, so we have this problem done. Let me do another one. Here we go. This one I was gonna have everyone try as well. I'm just so afraid though because we have less than 6 minutes left. So I'm thinking it might be better to, well, I'll post the notes anyway, but suppose Joyce paid $84.50, wait a minute, for some item in a store. It turns out it was marked off 35%. It's 35% off. Now the question is, what's the original price? When I say round to the nearest cent, that's the same as rounding to 2 decimal places. So we know that Joyce paid $84.50, right? We also know, hold on,